So in this video, we're going to be learning about the product and sum product to sum and sum to product rule. And yeah, so if you take a look at these formulas, we can see that what these equations are used for is that when we want to find an expression or an exact value for an expression like an expression like a sine value times a cosine value, or cosine value times a cosine value, or sine value times a sine value, or any of these any expression in the form of these expressions, then we can use these formulas to give a better expression, a simpler expression, or an exact value for your expression. So yeah, it's pretty straightforward what these formulas can be used for, and yeah, and how to use them. You just plug in the values. So yeah. So in this video, again, we're like the double angle formula video. We're just gonna be proving these formulas to just know like why these formulas work. So yeah, let's start with this one. Oh yeah, so these are the product to sum rules and product to sum formulas, and these are the sum to product rules. So here, this is a product and this is a sum, so it's product to sum, and here this is a sum and this is a product, so it's sum to product. So just remember it like that. So we're gonna start with the product to sum rules, and we're gonna start with this one. So again, we're gonna start with the compound angle formula. If you don't remember that, go to the compound angle formula video again, because yeah, that's the yeah. If you don't remember it, just review it again. So the compound angle formula, the formula for sine of a plus b is, if we recap our memory, it is sine of a times cosine of b plus cosine of a times sine of b. And then the formula for sine of a minus b is equal to sine of a times cosine of b minus cosine of a times sine of b. Okay, and we're going to add these two equations. Okay, let's see if I can draw a straight line. Okay, good enough. So add these two equations to get sine of a plus b plus sine of a plus b plus sine of a minus b is equal to, oops, let's make that bracket better, is equal to, and these cancel out, and we get here 2, and what we get here is 2 times sine a cosine b. We're starting to see something. And then we divide both sides by 2. So we get sine of a times cosine of b is equal to half of sine of a plus b plus sine of a minus b. There we go. So we just proved this formula. And I don't want to bore you guys by showing the proof for these 3 formulas, because these 3 formulas can be proved in a very similar way. So it's basically the same way. So instead of boring you guys by showing almost exactly the same proof like 3 times, I recommend you guys to, in your own time, just try proving these formulas using a similar method to this, like starting with the compound angle formulas and adding or subtracting the equations. Yeah. Yeah, that is the proof for this formula, and these 3 formulas can be proved in a very similar way. Yeah, and that's it for the product to sum rules, and we're going to move on to the sum to product formulas. So again, we're gonna prove this one first. Sine a plus sine b equals 2 sine, yeah. So for this one, we're not going to start with the compound angle formulas to prove this, but we're going to start with this formula. We're going to start with this product to sum formula. So firstly, let's say x, some variable x, is equal to a plus b, and y is equal to a minus b. then we can conclude from here that x plus y over 2 is equal to a, and and x minus y over 2 is equal to b. So let's note these four facts. We have to consider these four equations while we do our thing. So we're going to write this equation again. So half of sine of a plus b plus sine of a minus b is equal to sine of a times cosine of b. Yeah. And we're going to substitute these values into here. So here, let's rewrite this. So here a plus b is equal to x. So we're going to write x here instead. And a minus b is equal to y. So a minus b, so this is sine of y. And a is equal to x plus y over 2. So this is sine of x plus y over 2. And b is x minus y over 2. So cosine of x minus y over 2. There you go. And we just multiply 2 on both sides to get sine of x plus sine of y is equal to 2 times sine of x plus y over 2 times the cosine of x minus y over 2. And yeah, we just proved this formula. There you go. That was a pretty elegant proof. So again, I don't want to make you guys bored. So because these three formulas can again be solved in a really similar way to this proof. So I recommend you again to prove these in your own time. And to give you a hint, this formula was proved using this formula, and this formula can be proved using this formula, and this formula can be proved using this formula, and this formula can be proved using this formula. So just if you need a little hints, that's my hints for you to like prove these equations. So yeah, so basically this is the proof for this formula, and these formulas can basically be proved in literally the same way. So yeah, so that is the sum to product rules, and this is why they work. So yeah, in this video we looked at the proof for the product to sum and sum to product rules to know why these work. And yeah, it's pretty clear what they can be used for. Like if you see an expression in these forms, then you can convert it to this form to make it simpler or something. Yeah. So yeah, so that's it. This is that is the product to sum and sum to product rules. And then we have a video in the geometry section that uses all of the compound angle formula and the double angle formula and these rules, the product to sum and sum to product rules that we learned. So yeah, if you don't remember those, review all those trigonometric identities videos in this algebra section and go to that video in the geometry section to solve that problem using all the trigonometric identities we learned in this algebra section. So yeah, hope you enjoyed this video and see you